Alright, so here's our very first lab for our Security Plus lab. So as you will notice, we have a full network here, right? Which has an internal network, a DMZ network, and an outside network, right? Or an external network from the perspective of the firewall. So here, for me to show you how it's being done, we're using Packet Tracer tool. This is actually a Cisco simulator, right, where we can configure switches, PCs, and routers, and etc. Right? But for this lab, I'm just gonna focus on how to enable common network services such as syslog, NTP, and SSH. Right? So let me make this diagram bigger first. So just gonna focus on this set of routers. Right? So here for syslog, right, we're going to configure it on this switch, which is switch 3, switch 1, and switch 2. And all of the events and alerts will be forwarded to the syslog server. Right? So before you do that, ensure that you can actually reach the syslog server or ping the syslog server coming from switch 1, switch 2, and switch 3. So let's do that right now. So coming from switch 3, ping, then put the IP address of the syslog server. 1.11. Okay, so this means that I can reach the syslog server from switch 3. Next is validated from switch 1. Ping 192.168.1.11. There you go, it's working as well. Then we go to switch 2. 1.11. Okay, so the first task is good, right? So we can actually reach the syslog server from the switches. Now, let's verify if the syslog service on the server is enabled. So how to verify that? You have to go to services, expand this one, right? And go to syslog. And ensure that this service is turned on, right? If it's off, you just have to turn it on. And that's it, right? So if there's any event that is happening on this switches, right, this, it will be forwarded to the server and you should be able to see whatever is happening here. It's just like a list that you can see, right, on the syslog server. Right, so let's do that. Let's configure switch 3 first to enable forwarding of syslogs to the syslog server. Okay, so the config is actually straightforward. So just put logging host, then put the IP address of the syslog server, 192.168.1.11. Okay, there you go. Next is switch 1, config t, logging host, 168.1.11. Then switch 2, logging, go to global config mode, then logging host, 192.168.1.11. Alright, let's see if the syslog server has something in it already. Not yet. Okay, now, so what we're gonna do now, okay, from switch 3, we're gonna disable the uplink, or maybe let's disable the downlink instead, right? Because that's where the traffic is going. Okay, so let's disable switch 3. Oh no, the interface fast Ethernet 0/3 going to PC2, and let's verify if that's gonna appear in here. Right, interface fast Ethernet 0/3, then shut. Okay, you see that there's a syslog. There's a message here, right, that we shut it down. If we just refresh it, there you go. Right, so this is actually R2, or sorry, this is switch 3, right? So it's sending it from the exit interface, which is 10.12.12.2, because we haven't enabled DNS, so it's just using where it's coming from. All right, so we shut it down. Then the syslog server have the information that fast Ethernet 0/3 was shut down. Okay, now what if we disabled gig 01? Are we still supposed to get any notification from switch 3, right? Because this is the only path from switch 3 going to the syslog server. So let's see, right, what's gonna happen. Int gig01 shut down. Okay, we have a syslog here, right? Let's see if we can still get it, even though that's where it should forward it, right? Yep, there's a syslog. About a certain gigabit interface went down, but it did not come from switch 3. It actually came from switch number 1, right? Which is 10.11.11.11.1, this one, right? Because this is a directly connected interface going to switch 3. If we shut down this interface will also shut down. Then this guy will report .syslog going to the syslog server. Okay, so that's how it works. Okay, so let's re-enable it. I'm gonna enable the other LAN interface. So shut. Just refresh, go to other service, and go back. There, yeah, it has reported that that interface. Let's see. It went up already. Okay, yep, we have a lot of logs here. What's this? Yeah, change state to up. Right, this is when we enabled the port coming from switch 3. Okay, so this is how syslog works. Of course, there's a lot of syslog application that you can install, right? So, but this is the main concept on how syslogs work. Okay, so in security, right, it's very important that we understand the events, the alert that is happening in the network infrastructure, so we know exactly where to troubleshoot, right? We cannot just look at the firewall directly, or if there's a virus, right? We have to look on the underlay as well. So if you know the OSI layer very well, in troubleshooting, you have to start from the bottom, right? Maybe it's just a cable disconnected, right? Or maybe you have a layer 3 issue, a routing issue, right? A neighbor down, something like that. The syslog should be able to capture that and forward it to the syslog server. Okay? There's actually some designs where the syslog server is reachable not from the in-band, right? Because this in-band reachability, right? So what's going to happen here? If this goes down, right? It's part of the in-band traffic flow. This guy will not be able to forward any traffic to the syslog because it's in-band. On best practice design, right? Syslogs, this servers, you can put it on an out-of-band network, just like switch 3 will have another network at the back, that will be able to reach the syslog server. But of course, it depends on how huge the network is. Normally, it's being done on data center networks. Okay. So yep, that's it. We're able to verify syslog is working. Let's move on to the next task, which is NTP. Right? So NTP is also important, right? So if we have syslog working, we gotta ensure that we can actually correlate all of the syslog. What if the event is happening on all of the 3 switches? However, the timestamp are different, then how are we gonna correlate all of these events? That's why we have to ensure that we're actually relying on an NTP server that has the correct time and dates, right? And all of these switches will just poll or follow whatever time is in the server itself. So on this lab, we have an NTP server which will be our clock source for the network. Okay, so whatever time we have here on the NTP server, that should also be the time and date on these 3 switches. Okay, so again, this is very important for correlating events between all of these switches. And it's not just about enabling NTP. We have, as a best practice, ensure that we have security involved. Like switch 3 should authenticate via the NTP server, right? To ensure that, hey, we have the same key, then it means that you're the correct NTP server where I should get the time, right? Because if you don't have any key or authentication involved, anybody can just connect an NTP server and just copy the IP address. But apparently, right, if you don't have that key or any security feature there, so this guy can use the NTP time and date on that let's say a rogue NTP server, which it's not going to be great. Okay, so on this lab, we're also going to configure that particular security feature to ensure that, hey, I'm using a valid NTP server. Right? So let's again, first is ensure that we have reachability from switch 3.1.2 going to the NTP server 192.168.1.10. So let's ping that 168.1.10. All right, this means that we can reach it, right? Ping. Yep, we can reach that. This guy. Okay, all of them can reach it because it's just on the same internal local area network. Okay. Now, how do we configure it? The first thing we need to do is to at least check also the NTP server, right? If we have the service running properly. So click on the NTP server, click on services, and go to NTP, right? And ensure that this is on, right? And you have to define the authentication part. So you have a key, so let's put 1, and the password will be Cisco321. All right, then we should be ready now to, to configure the switches to point to this NTP server and copy whatever time and date it has on the NTP server. Okay, so let's now configure the switches. Okay, so switch 3 NTP server. So this is how you tell switch 3 that, hey, this is the NTP server, right? NTP server 192.168.1.10. Then we also need to ensure that we have the same calendar, so NTP update calendar. Then we enable the authentication, right? So there's actually 3 lines, right? So the first one is NTP authenticate, NTP trusted key 1. So this key is the same with what we have here, right? Key number 1. Just copy it. Then you have the NTP authentication key 1 MD5. Then put the same password. Remember, we have a password here, Cisco321, so just put that, right? Of course, on the best practice, put a much more complex password, right? So on this lab, we just put some simple passwords just to make it easier for us to, to authenticate and log in, right? But in the real production network, ensure that you have a much more complex password using like a minimum of 8 digits and a mix of numbers, or it should be alphanumeric, and put some symbols in there. Okay. All right. Then let's go to switch 1 rather. So tell the switch to, hey, this is the NTP server 1.10, NTP update calendar, then authenticate, NTP trusted key 1, NTP authentication, key 1 MD5 Cisco321. Okay. Then switch to NTP server 192.168.1.10, NTP update calendar, NTP authenticate, okay, trusted key 1, NTP authentication, NTP authentication key 1 MD5 Cisco321. Oops, there's no dash. Oh, another command that we should add is the service timestamps log date time in millisecond. Date time. Yeah, just to ensure that we have the correct, we put timestamps on all of our logs that will be forwarded to the syslog. And we have this kind of granularity with the up to the millisecond value. Okay, so let's add that as well to the other switches. Timestamps, log, date, time, millisecond. In switch 3, service, timestamps, log, date, time, millisecond. All right. So how do we verify if this is all working now? So there's this one command, right? Show NTP status. Okay, oh, this is actually quick, right? So we can now see that this switch has synchronized to the NTP server. Okay, so this is switch 3. Let's verify the others. Show NTP status. This one is still unsynchronized. So typically it will take you like 2 to 3 minutes, right, for this guys to synchronize for the NTP server. So NTP status. Unsynchronize. Now let's just wait for a couple of minutes, right? So we're just gonna check. So this now synchronized. Still unsynchronized. So if the synchronization takes some time, right? Ensure that verify if there's something wrong with your config, right? Maybe it take you like it's already 10 minutes past, but it's still not synchronized. Ensure that I'm gonna check if there's anything wrong in the config, like the password. Have you put the trusted key, right? Something like that. Switch one. Switch one. Okay, this guy is synchronized already. Earlier it's not, right? Now it's synchronized. What about switch 2? Still unsynchronized. Okay. And there's also another command here, NTP association, for you to see to which NTP does this guy talk to. Okay, so this is 192.168.1.10. All right. Okay, now switch 2 has synchronized as well to the NTP server. So when we do a show clock, it says 1612 Feb 2 2021. Let's verify if that's the same. This is the same, right? Feb 2, it's showing 412, but this is showing military time, which is 16. 16 is actually 4 as well. 413 or 412. Yeah, there's just a couple of seconds lag, is it? 6:13:10. Oh yeah, it's just the same, right? So it's actually the same with what we have in the NTP server. All right. So great. So this is all working. So syslog NTP working. Now let's configure SSH access to all of the devices. Okay. So here, right? So SSH it's just a protocol that you use to be able to communicate or access these devices if you want to manage it, right? But here in Packet Tracer, if you click on the device itself, you're actually going to the console port, right? So for you to check that, go to the privilege mode. If you do an exit, you can see that hey, you're connected to the console port. Okay. But if you're coming from switch PC1, you will communicate, you will access the devices via in-band. Right, so if this link goes down, you're not going to be able to access switch 3. Right, so you have to ensure that in-band works and this is reachable from PC1. So before we configure that, let's verify if these switches are reachable from PC number 1. 10.1.1, it is. And switch, oh, this is switch 3, sorry. Switch 1, what's the IP address of this guy? 10.12. ping 10.12.12.1. Alright, so I'm just using the physical interfaces. But on standard networks, there should be a dedicated management IP for these switches. Right? Maybe either a VLAN or maybe a loopback. It depends. Okay. 10.11.11.2. All of them are reachable. Great. So how do we configure it, right? So let's start first with switch 3 because this is a directly connected switch from PC1. So it doesn't matter really because we can reach all of the switches anyway. Right? So how do we configure? So the first thing that we need to do is to configure a domain name. Okay, so go to global config, IP domain name, and put our website, howtonetwork.com. Okay, then what's the username? Username howtoadmin, secret howtopass. Right, that's our secret password. Howtoadmin and howtopass. Okay, then next is configure the enable secret. Same, howtopass. Okay, that's step number 3. Now, if you're going to SSH or telnet to the switch, right, you're actually going to the VTY line, right? So you have to access the VTY line config 0 to 4, okay? Then log in, right? So here we're not going to use AAA yet, but the authentication will be local, right? For now, log in, local. Then transport input. So here you have an option to set all, so it means it can accept SSH and telnet. It can accept only telnet, and if you want SSH, just SSH. On this lab, we're just going to use SSH, right? Because we want the access to be secured. Because with telnet, you're actually sending the username and password in clear text. If somebody is sniffing packets on the line, they will be able to capture that. But with SSH, it's much more secure. Okay, so this is going to be SSH. All right. The next step is to do a crypto key 0 is RSA, right? So we have to ensure that there's no key configured on the switch, so we have to remove that first. There, so no signature RSA keys configured. So let's go ahead and generate a new one. Generate RSA. Right, so by default it's 512, but as a best practice, minimum should be 1024 or 1024. Okay, then some other additional changes, right? For SSH, you set the timeout to 90, IP SSH, then put an authentication retry of 2. Okay, then IP SSH version 2. Okay, that's it. This is for switch 3. So let's SSH to switch 3 coming from PC1. SSH -L howtoadmin 10.1.1.1. All right. But the fact that we're being asked with a password prompt, it means that we're able to connect to the box. Okay, and just ensure that you have the correct password so you can log into it. So the password is how to capital PASS. Okay, we're able to log in and go to config mode, to the privilege mode, how to PASS. There you go. All right, so yep, we're able to SSH to switch 3. Now let's configure switch number 1. We're just gonna follow the same set of config. IP domain name, how to network network.com, and username how to admin secret how to pass, enable secret how to pass, line VTY 0 to 4, login local, transport input SSH, okay, then exit crypto key, remove if there's anything configured, so none, crypto key generate RSA, so put 1024 here to be secured, to be more secure, right? Then IP SSH timeout 90, IP SSH authentication retries 2, IP SSH version 2. Okay, switch 1 should be done. Let's verify it from PC number 1. Exit from here. SSH 10.12.12.1. Nope. SSH minus L. How to admin 10.12.12.1. How to pass. How to pass. Oops. Let's try again. Because I only have 2 retries, right? So after 2 retries, it's gonna disconnect. So that's the setting that we configured earlier. How to pass. All right, we're able to get in. Enable. How to pass. There you go. Okay, so we're able to log into switch 1. So let's go to switch 2. Switch 2. Okay, for switch 2, let's start with IP domain name, right? Again, how to network.com, username how to admin secret how to pass. Okay, enable secret how to pass, line VTY 0 to 4, and login just local, transport input SSH, then exit, then your crypto key 0's RSA, then crypto key generate RSA should be 1024, right? Then you gotta set again the SSH specific config as IP SSH timeout. It's actually in seconds, right? Then IP SSH authentication retries 2, IP SSH version 2. Okay. You know what? Let's save this as well. Save and okay, then the other one, switch 3. This guy. Alright, from PC1, let's try again if we can connect to switch 2. Exit, right, because we're still connected to switch 1. SSH minus L, how to admin. How to admin 1. The IP is 10.11.11.2. Okay, so we got a password prompt. We're able to connect via SSH. But sometimes it's not gonna work because there's a software version mismatch, right? So you have to fix that first before you will be able to log in. But for this one, this should be good. How to pass. Oops. How to pass. Okay, great. How to pass. Okay, there you go. All right, so yeah, that's the end of the lab number 1, right? So just to recap, so we enabled syslog for all of these 3 switches to forward it to the syslog server here. We also enabled NTP, so this guys will sync its clock, right, to the NTP server on the left. And we also enabled security feature, right? Like we add a password for them to authenticate to. Then we also have enabled SSH. So PC1 will be able to SSH to all of these switches, correct? And we also configured a couple of features and best practices for SSH on these 3 switches. All right, that's the end of the lab. Thank you very much for watching.